Good morning, good afternoon, good evening, everyone, depending on where you are tuning in from today. My name is James Finton Bland. I'm the Global Developer Relations Lead for Zebra Technologies. And today we have a very interesting presentation from Jarek. Just before we get into the detail there and I hand over to the expert, we just have a couple of housekeeping rules. So the first thing to bear in mind is that all questions can be entered into the question box on the GoToWebinar sidebar. We'll get through to those questions at the end of the presentation. We'll go through those one by one on a first come, first served basis. The presentation itself is being recorded and we'll be uploading that to YouTube on our Zebra DevTalks playlist, usually a couple of days after the event, so hopefully by the end of this week. So just before we get started, if you could go to the next slide, please, Jarek. Thank you. So yeah, just a quick plug here to make sure you're all aware of our different sort of community touch points. So please do make sure to, follow us on the social media platforms that you see there on the right-hand side. And if you haven't already, also check out our developer portal, which has just gone through a nice redesign there as well. So you can do that at developer.zebra.com. It's a good place to ask all of your questions and find out a little bit more information about Zebra. Next slide, please, Jarek. Last thing from me, I promise. So just a couple more quick heads up about some events that we have coming up. So next month, our Dev Talk will be around introducing the electronic temperature sensor solution. So we have a brand new product released from Zebra here for measuring temperature through the transport and logistics verticals, as well as some other verticals as well. So a brand new announcement there. We'll be going through some of the SDK stuff, as well as the API stuff and an overview of the hardware as well. So one to tune in for. And then a couple of in-person events this year as well. So we'll be at Joy-Con Berlin and London. So if you're around, please do make sure to come and say hello. And then very importantly, we have DevCon as well coming up in Madrid. And that'll be September 13th to the 15th. So registration opening for that soon. In the meantime, just save the date in your diaries. So that's enough from me with the introductory stuff. I'm going to hand over now to Jarek, who was going to be your expert today and take you through all of the details. So the stage is yours.
Hi guys, my name is Jarek, and I'm very happy to see you at this webinar, part of the larger Zebra Dev Talks. I hope that we're going to have a nice 30 to 45 minutes together. There should be fine. Okay, so the topic of today is what's new in Zebra Aurora Vision Studio 5.3. Now, some of you may recall me from some other Zebra events, both hosted online and in person. I am a computer vision application engineer at the Aurora Vision team, Zebra Aurora Vision team, headquartered in Gliwice, which is in southern Poland. And while the purpose of this webinar is to introduce you guys to some of the new functionalities within our software, within our offerings, I also want to make sure that everyone is on board all the way through, that those of you who have not really had much exposure to Zebra Aurora Vision, or maybe haven't even heard of it before, they can also get up to speed as we go along. So the agenda for today is first off, just like I promised, we're going to have a brief reminder as to what Zebra Aurora Vision actually is. We're going to talk about the larger Zebra Aurora Vision, not just Zebra Aurora Vision Studio, even though this is actually going to be the main focus of today's webinar. Once we're through with that, we will go through just how it is that you can use Zebra Aurora Vision. Well, more specifically, actually, this is going to focus on Zebra Aurora Vision Studio. And then once we're all safely on board of the same vessel, we'll be free to head off to describing the new important features that were introduced into version 5.3. So while those of you who have had long exposure to our software, this will truly be of most interest to you guys. I'm firmly of belief that those of you who are not really that much familiar with us will also on this on this basis alone will be incited to check our software out, and rest assured that all of you guys will be given an opportunity, and I will give you guys more info on that at the end of the webinar. And so, as we focus on those important features, we will describe primarily the newly introduced support for Zebra handheld scanners, or more precisely the Zebra scan engines, which can now be used as image capturing devices in Zebra Aurora Vision Studio as of version 5.3 of our software, which is actually already in the beta stage of development, available on our website. Then we will show you just that the fabled Zebra code reading algorithms are also now available directly in Zebra Aurora Vision Studio. No more tweaking around, no more, working, putting an extra hour and extra effort to actually combine the results that you want using the barcode inspection with the other machine vision functionalities offered by Aurora Vision Studio. All of that is gone now. Everything's perfectly integrated. And finally, this one more of our own internal novelty, a new deep learning tool, namely text location, to go on top of the basic optical character recognition tool, which is also running off a powerful deep learning pre-trained model. And so we will focus on all of those. But then, just to drive the message home as to what it is that you guys can expect, there will be an all-in-one application showcase towards the end of this webinar. So I hope by this means you will be able to fully appreciate the scope of the changes that are now that have recently been introduced to our products. And finally, we have a question and answer and Q&A session. As usual, all of your doubts and questions, I hope most of them will be addressed. Okay, so let's just jump right into it. Again, the brief reminder as to what it is Zebra Aurora Vision in general. So our offerings include a comprehensive range of software products for image analysis, machine vision to be exact. And we have first off, we have Aurora Vision Studio, which is our flagship product. And so the key feature behind this product, Zebra Aurora Vision Studio, is the ease of use, is the convenience of use by everyone. By everyone, I mean people who not only have had little to no exposure to machine vision in particular, but even software engineering in general. This is a very user-friendly thing, which is capable of turning into proficient machine vision engineers, even people with little to no actual engineering background. And as I hope those of you who have yet to be convinced will soon, be convinced as we go along, or as you are able to test our software yourself. So the workflow is extremely simple. We have, like normally, you have multiple machine vision functions that you have to combine together. For Zebra Aurora Vision Studio, we go the extra mile, and we actually combine those features together. Those functions are combined into filter blocks, and and then all you have to do, once you've stacked a few of those filter blocks on top of one another, you have to just connect outputs to inputs. You can preview the outputs, you can preview the results, and that's basically your whole application. It can be created very easily, very fast. However, just because Zebra Aurora Vision Studio is our flagship product does not mean that we forget about those of you who would prefer to deal with code alone. every one of your applications can be that you do in Aurora Vision Studio can be, you can generate C++ code out of it. It also comes with a .NET wrapper. Naturally, you can create your own application from scratch using Zebra Aurora Vision library without even touching Aurora Vision Studio. That goes without saying. But the purpose of the reason why we publish not just our graphical user environment, but also our library, bare bones library, so to speak, is not just because some people prefer programming, maybe like doing regular coding, but primarily to make it easier for you to integrate your own application, your third-party application, with your own algorithm that is done in our library. When you have the bare bones C++ code, then it shouldn't be. It should no longer be an issue. And finally, aside from Zebra Aurora Vision Studio and the Zebra Aurora Vision library, we have the deep learning, a tool set of deep neural networks that were entirely in-house developed and are now were made available by means of regular filter-based tools that you can use directly in your Zebra Aurora Vision Studio application or your Zebra Aurora Vision library application, if you prefer. So in this webinar, we're actually not going to focus too much on the deep learning aspect, aside from optical character recognition, but this is something for you guys to keep at the back of your heads as we go along. If you have further questions, if you are more interested in our primary deep learning tools, then you can consult some of our other webinars that we did in the past, or our website, our documentation. So just to briefly sum up, what is Zebra Aurora Vision Studio and why this is something that should be your choice when it comes to machine vision applications. First off, because it enables rapid development. Doesn't matter no matter what your background is, it will always be significantly faster to not just program, but also debug later down the road. It remains easy for use both for experienced engineers as well as just complete novices in a way. None of it which, however, comes at the cost of the solution's power, because we boast way over 2,000 right now, I think, reliable and field-tested tools that have also been optimized for even extremely demanding applications. It's a very mature solution, which is to say it's an old one, but obviously constantly updated, because we actually have a policy of supporting our customers in very close proximity, so to speak. We enjoy getting feedback and we enjoy addressing this feedback. This is something every one of our partners emphasize when comparing us to some of the competitors, because, well, we basically take people's feedback seriously. That's what enabled us to have the solution mature as much as it did over the past 15, well, it will be 16 years right now. And finally, because it's hardware agnostic. And basically, you are free to use any device as long as it meets some requirements when it comes to the communication standard, and even whenever you need to provide communication with a device that may not natively work in Zebra Aurora Vision, it is still remarkably easy to integrate proper lines of code into your Zebra Aurora Vision Studio application. Okay, and now just how do you use Zebra Aurora Vision? So let's just now go to the application itself, the application window, and we're going to see an example. As you can see, this is Zebra Aurora Vision version 5.3, which is still in the beta version. It will be pulled soon, most likely sometime in April, For now, however, we will be using the beta version, and we're going to have a look at one of the examples. And this is basically where all the magic will happen. Everything that you need to know concerning your machine vision application is available here directly. As you can see, those are the filter blocks I kept talking about, stuck on top of one another. We got outputs connected to inputs on a very simple basis, so just drag and drop, basically. The same goes to the preview window. Any output or even input can be directly displayed within the preview window. And to the left, we have the structure of our application. This application is actually very simple, but if we were to have more macro filters, in fact, if I can just add one now, it will appear here by means of a tree that we can access at any point in our work. And every filter comes with its own parameter setup that you can adjust at any time. Some of those inputs you can modify even while reviewing a paused iteration. So not every change in your application demands the whole application to be restarted. You can use a variety of viewing modes, some of which make it possible for you to follow whatever is happening at the given stage. For example, in the case of this filter, we can see that the point-to-point distance, we can see that the actual distance between the points is showcased, and the outputs of those filters, of this filter, are also conveniently available in all of the preview windows. So that's pretty much just how we would go about when it comes to building our own application, as you will soon find out. So I think that those of you who may not have had the best idea are now probably should be able to tell more or less what it is that you are dealing with, hopefully. If not, your own experience, I'm sure, will clarify more than any presentation could ever hope to. For now, let's, however, get back to the presentation and focus on the novelties that I mentioned. So first of all, what we introduced here, and something that we believe pretty much proves just how well integrated our solution, our product is with the core Zebra offerings, such as the Zebra scan engine. Just a word of explanation, because I didn't mention it before. Those of you who don't know, we used to be our own company prior to the acquisition by Zebra Technologies, which happened almost 2 years ago. That is why, even though we got rebranded, and so the old Adaptive Vision was turned into Aurora Vision, and sometimes you will hear the old name used as well, even during official meetings. So just bear in mind, those are the same things: Zebra, Aurora Vision, or Adaptive Vision, same thing. And as of version 5.3, we can really see this relationship thrive, this internal relationship nowadays, of course, thrive in the form that we actually support official Zebra products, such as the scan engine. Here we're using the Zebra handheld scanner DS 36 3608. But this filter that enables us to use this scanner as an image capturing device will work with anything that uses the Zebra scan engine or the Zebra scanner SDK. And it works just like any other filter in our software, meaning that you basically add a block that says Zebra scan engine. In this case, you grab an image, and then its output, the image is output in the preview window, and you can select the whether it should be triggered, whether the image stream should be triggered, or whether it should be in continuous mode. Another thing that we introduced to version 5.3 is the support for Zebra code reading algorithms. And I think I may have actually, I'm very sorry about this. I think I may have misplaced the description for the for the slide here, because this is actually supposed to say about the code reading capabilities. I'm sorry about that, and this will be fixed. So the idea is that even though internally our Zebra Aurora Vision Studio has always offered its own code reading algorithms, but Zebra naturally has also its own image kit, very powerful tool, and at some point it was just common sense to make sure that if for whatever reason you'd prefer to use the actual Zebra image kit while doing your own application in Aurora Vision Studio, then we should not be making it any harder than it needs to be. That is why we introduced this filter that covers it all, that will enable you to read all of the codes that are supported by the Zebra scanner image kit. So, and you use it again just like you would any other filter. You output the outline of the barcode, or the data code, in this case a data matrix, and we can output the result as well. And then finally we have the text location tool. Now, those of you who have followed our software for the past 2 years or so should be familiar with our deep learning based optical character recognition tool. It was a true revolution when it came out, and we've had some amazing feedback from our customers. But in spite of all that, we still wanted to make one step further when it comes to assisting our customers. What is powerful about our deep learning optical character recognition tool is that it comes with a pre-trained model, meaning that it's basically just the epitome of plug and play. You don't have to train any model yourself. You just capture an image, use the filter to read characters, and there you go. There you have your results. However, the drawback of this tool, just like you would have in any optical character recognition tool, is that for the tool to work properly, the text has to be aligned pretty well, more or less horizontally. It didn't have to be exactly level, but it still was generally not seen well if it were twisted too much, or if it were tilted in some other way, primarily because many letters can be interpreted alternatively whenever they are rotated in any way. The text location tool, the DL locate text tool, was built to mitigate this at least somewhat, because it's very hard to do it 100%. It's very hard to make sure that you always will get the correct text alignment, but it definitely will make it easier. So for example, the text on the camera box that said zebra, it used to be not legible in version 5.2 because of how tilted it is. But now it was made possible in version 5.3. And so what we do is we have the text location tool output the results box, and then we use the alt character reading tool that now knows the alignment of it to read the text as it should. Okay, so now just to have it all wrapped together, we have the all-in-one application showcase. So what we'll be doing here is that we're going to use the Zebra handheld scanner DS3608 to capture images of printed thermal indicator labels. Now, maybe I will show it here. You can see that the thermal indicator here, depending on whether it's full or not, it gives you the information on the temperature. This is of course printed. It's not the actual thermal indicator. This is just the label that we printed. But even with the real thing, the inspection would work the same thing. We're basically detecting whether the circle is full or not. But aside from that, we're also going to perform code reading, and we're going to perform optical character recognition, which will take advantage of the text location tool. So we will be outputting the results, the properly calibrated, properly adjusted images of individual labels down below. So so without further ado, I think we can move to the application. Okay, as you can see, I'm going to get the proper results in a minute. Just I wanted to show you that we're using the handheld scanner to scan the boxes. So I'm just going to try to get it correctly, but it's a little hard from this angle. But okay, yeah, we got it. All right, so so let's analyze it maybe a little bit. What is it that we are doing here properly? And so first off, in the application, we're deploying the deep learning tools. That is in order to improve the performance of the application later down the road. We just deploy it at the time during the initialize stage of the application, and then it all works faster later on. Then we use the Zebra scan engine grab image filter to capture images based on the snapshot mode, which we can change to video mode, but we're not going to be using this. I know that the image from the webcam that is capturing those boxes may be a little bit jittery, so I'll try not to move it too much. But I think you can understand that we're using the handheld scanner to capture the image of the boxes. This is the image that we're seeing here, and we can see that the results have been output. So what are those results? First, we read the code using the ImageKit filter. We read the code, we get the code format and the code result output down here. However, that is not the only purpose why we have this why we do this inspection, is because we also use the code to get a proper alignment of the label that we want to output in the cropped images below. This may be a little confusing because here you can see that the box on the left was highlighted as moderate because it doesn't have the it's not filled in, and the one on the right was highlighted as high because it is so the temperature is high because it is filled in. You can see that they swapped their swapped position. That just basically because that one was read the first and this one was read the second, but that's the only thing. Then we locate the text and then we perform the optical character recognition on it. It's not always going to come out 100% correctly, but in this case it looks like we do get the proper results. Of course, this actually, the box on the right wasn't captured in its entirety, but what we can see, we actually managed to output properly. There is an option then to merge the characters into lines. That way you can get rid of quite a few false positives. For example, some individual characters, supposedly characters that are actually just some kind of scratches or anything. This tool is actually very useful. Here in this grouping, we perform a little bit of calibration. We can see that we create a rectification map just to get a proper fix on the coordinate system, just to make sure that the cropped images are being displayed properly. We also, in this filter, we also perform inspection of whether this area here, namely the area that's aligned here vis-a-vis the code, or here vis-a-vis the code here, whether it's filled in or not, and that gives us the idea as to whether this is a moderate temperature indicating label or a high temperature indicating label. We have a few additional filters here that have to do with the mapping of the image, but we can skip those. Then we draw the results that we have, and based on whether we detected two boxes, two labels, or just one label, or either no labels or multiple labels, more than two, we will be getting different results. In this case, we got the number 2 for our boxes, which is why we are in this branch of the application. There are multiple ways in which you could approach this particular case. This is the one I decided to tackle this with. Some other people will use a different approach, maybe a bit more flexible. For that, I wanted to make sure that we get all the results nicely laid down. So at the end of the day, what we end up here is that even though we have the images of the image of the boxes that are distributed quite widely across the image, we still get them nicely cropped out. Of course, this one is, well, maybe partially obscured because it was the scanner didn't manage to capture it in its entirety, but we get what we wanted. We got the code, we got the text. The text is also highlighted here. in the cropped images, and we got the proper conclusion concerning the thermal indicator inspection. And that's pretty much it. We can try to do it sometime more. In this case, we didn't manage to get the code. That's why it was a little maybe we can try this. See, just like you saw on the image of the inside the presentation, we can still stack them on top of one another, and you can see the image, the boxes are tilted from the perspective of the scanner, but still we get quite nice, again cut at the top because, well, the field of view is quite limited, but still the cropped images are properly lined out. And that, I think, brings us to the end of this presentation. Thank you very much for listening, and I will take your questions now.
Thank you very much, Jarek. Nicely done there, despite a few issues out of your control. I think you handled it quite well, so thank you very much. That was a great presentation. So we only have just the one question so far. We've got a few minutes here, so if anyone else has any questions, please do feel free to put those into the questions sidebar while we work through this one. So first question here from Nathan. He asks, how are the images coming from the scanner and into Aurora Studio? Is it via the network? Is it on the scanner itself?
It's actually if you can still see the presentation here. I mean the application.
Yep, we can. Yep.
This is how it goes. So just USB.
Okay, perfect. Next question here from Dan. Is it available within Data Wedge on Zebra Android-based scanners?
Come again?
Okay, so this question is around a piece of software that we have on our mobile devices called Data Wedge. So the question is any of this tech available within Data Wedge on Zebra Android-based scanners?
Okay, so first of all, when it comes to Android, support for Android, this is a topic that's in hot development right now. I'm not familiar with any attempt to make it available directly on this kind of application, but that's definitely something we should be on the lookout for. When it comes to our solution, our tools working on Android devices in general, like I said, we actually were thinking about maybe showcasing some sort of demo about this, but we ultimately decided against it because this is still very much a work in progress, and this is not something you should expect in version 5.3 or even version 5.4. So for the time being, I would say that the answer to the question here is no. The long-term answer for this, it will depend.
Very well answered, thank you. I suppose that leaves a bit of a gap perhaps for an entrepreneurial developer to maybe have a stab at it themselves, I suppose, but maybe a discussion for another time. So a question here from Thomas. What is TME and speed of, what is the time and speed of capturing?
Okay, and we can actually have a look at, in Zebra Aurora Vision Studio, we actually have the option to check the program statistics. And here we see for the grab image, it's at well, obviously it's not 70 seconds, but maybe if I just do the video mode. Okay. For now, what we get would be almost 6 seconds. I'm not sure how reliable those statistics are in this case. But yeah, we get more or less like 5 seconds, which I wonder is because actually I haven't really consulted. I haven't really worked too much with the handheld scanners before as image capturing devices, considering that they are manual triggered. So I'm not really sure right now whether I'm interpreting this correctly, but this is, well, the average iteration time for this particular filter would be around 5 seconds.
Okay, understood.
Mm-hmm.
So where are we? A question here from Rob. Can a wireless scanner be used as well?
A wireless scanner. I don't think so. This is actually something because we've been working on. Well, the question is because again, I'm sorry, just maybe it's just my ignorance coming through. But when it comes to the Zebra scan engines, well, we've so far worked only on those that are connected directly. They are not working wireless. So for this, I'm not really sure. That's something I definitely would need to check. For now, I believe that since we do not have any accompanying, so to speak, camera manager when it comes to the Zebra scan engines, I would assume that the answer is no. But that's something very interesting that I will definitely have to check. I recommend that for those of you guys who are interested. I don't know if the email address can be written in the chat of the webinar for av-support@zebra.com. Maybe I will write it momentarily once we're done with the Q&A session. Or James, can you type it?
I've done that. Yeah. So it's av-support@zebra.com.
Mm-hmm. Yes.
So please email your question over there, and we'll get back to you.
Yes.
One thing I would say is I don't know because it depends on how we've integrated the scanner with this software. But if we've used our traditional scanner SDK, I believe it has a core scanner layer, which means that it should be irrelevant what protocol you're using to connect to the PC, whether it's USB or Bluetooth. And it's
quite possible. It's just that because honestly, for every single time we've worked on the Zebra scanner SDK, it was always over wire. So it hasn't really even occurred to me or many other people, I'd say, to even ask whether it works on the wireless scanners. It's quite possible that this is exactly how you say, but I just can't really say without consulting it first. So sorry guys, just
no, it's better to say you don't know when we don't. We'll hedge our bets there. So
absolutely.
We'll get back to you with a concrete answer. Okay, we've actually got quite a few more questions coming through here, so let's try and work through them. So another question here, a follow up from Thomas. So the previous question was around the time and speed of capturing. This question is now asking how many characters in a second. Is that something we can look at?
How many characters in a second? This is something. Let me just make sure that we get the right inspection. Okay. What? I'm sorry. Just I have to like.
Some bespoke testing for you here, Thomas.
Okay, we got a nice result, and now. Okay, so just for us to interpret the statistics properly. What you see here is the read characters deploy. What is happening, what is this concerns is this filter right here. This is the initialize section filter, meaning this is deployed only once at the start of the iteration. And at least in theory, it should ensure that every subsequent iteration, aside from the very first one, works much faster because the model is already deployed. To tell you, to be 100% sure, honest with you guys, it's not always, it does not always yield exactly the kind of results you would expect. Sometimes the difference is very negligible, but still we always recommend using those deploy filters. But just to focus on the question here is that, so the read characters deploy tool and the locate text deploy tool are both executed only once at the start of the iteration. Then to read the characters in every iteration, we need 184 milliseconds. Yes, and for location, the location tool actually takes up a little bit more. In this case, I would say this would be about 400 milliseconds for all of those images. Not images, for all of those characters. But I would actually like to show you guys our official read characters optical character recognition example. There is a delay filter here. This is a very simple example, a very bare bones ones, but it's most representative of all. And in this case, you can see a quite limited number of characters and a smaller image, or just 400 per 56 pixels. We can do it all in just under 15 milliseconds. So, as usual, the least satisfying answer of all, it depends.
Often the most accurate answer. Thank you. Okay, so a question here from Barbara. The OCR is recognizing text. Can we also capture etched or engraved text? I think the answer is yes.
Yes, we do. We can indeed capture those this kind of text. And actually, if you just give me a second, because this is not something I have directly on me, but this, I've just accessed another presentation. I hope you guys can see it.
We can, yep.
See, yeah, sorry. Those are just some examples of the kind of text that our tool has been applied to.
Awesome.
So,
perfect.
Yeah, so that's as you can see, it's quite impressive. Now, obviously, like, to be level with you guys, it's not always going to come out as neatly as it does here. This is a marketing material, so you guys should be aware there are limitations. Some tweaking may be necessary, but generally speaking, our tool has met great feedback from users all over the world, and it's in very hot demand right now, and it has indeed been applied to difficult cases such as this one.
Yeah, I think no one can fault your honesty anyway. You saying it how it is, so we very much appreciate that. Okay, can we also extract graphics, or is it text only?
Graphics?
Yep.
I'm not exactly sure if I understand.
So that was kind of the question word for word. Can you also extract graphics? My interpretation of that would be perhaps image object recognition, things of that sort.
Image object recognition. No, well, when it comes to the optical character recognition tool, this is just for, you know, for characters. Any sort of other interpretation of what object we can see on the screen is dedicated to primarily our other deep learning tools, such as classify object or locate objects, we have quite a few. For optical character recognition, then no, it's just text. If there's something to the question, to the person who asked this question, if there's something I misinterpreted about this, it would probably be best if you just simply, if you write us a question at av-support@zebra.com, and we'll try to get to the bottom of this.
Okay, no problem. Yeah, or likewise, we have a few minutes here as well. So if you can add in a little bit more detail to your question, I will see if we can get around to it today as well. Okay, so the next question here is, what is the smallest font size it supports for OCR?
The smallest font size, for example, in this, the smallest font size it supports is 8. And you will see that it means it's just 8 pixels. Well, more or less it should be 8 pixels. Below that, we consider the text, any sort of OCR inspection result to be unreliable. We generally recommend, that's why the default setting for this is just 35 pixels when we adjust the character height. Bear in mind that this is indeed the actual scope of the character here is not just 35, but I would say between 20 and 50. I don't remember exactly the percentage of it, but the scope is quite vast. So if you have characters, some of them are 20 pixels high, some of them are 40 pixels high, and some other are 50, then I would say that the character height of 35 would be the nice compromise. So always just try to hit the middle ground. For I'd say even 8 pixels would be kind of a stretch. I would probably avoid having text this small. I would probably just move the camera a little bit closer if possible. But yes, but even here we've managed to. Let me just find it, because this is actually an interesting example. Oh, this is this is an example of a successful inspection, even of a very blurry text. Let's see how many. I don't really know how many. Like 3, 4, 5, 6, 7. So like 14 pixels or so. Not that much more than 8, but we can see that it still gives us enough leeway for us to do some reliable inspection. For 8 pixels though, I would have my doubts, but it's always good to try.
Fair answer, very thorough, thank you. Okay, so a question here from Andre. Can we do an interface IHM with this software? So can we interface
HMI?
IHM? It says IHM, perhaps it's a
No,
typo.
I think it says the Andre is like, so I guess in French it would be like IHM, human machine interface. Yes, absolutely, we can do it. We can do this as a very simple application that I have right now. We have the HMI designer over here. So what we can do here is we got the. I'm just going to show you very briefly how quickly you can do it. I just want for the human machine interface to show me exactly the same thing that I can see on the preview window. So let's see if I can. Yeah. And we can adjust it however we want. We can have the let's say you want to have the text, the actual text, the actual text results output. No, this would be and there we go. You have some nice text that you can copy and paste elsewhere. So there are a multitude of options. We have a whole documentation entry concerning our human-machine interface. So yeah, we got discovered this is a very important point of focus in our software development.
We weren't joking when we said you were the expert. You're building demos on the fly, pulling out resources.
It's just how awesome this software is. It's even I can do it quick.
Excellent salesman there. Thank you. Okay. Is there a list of compatible Zebra handheld scanners that work with the shown grab image filter?
Like I said, this is we haven't tested all of them. In fact, we tested just a relatively little number of them. The general idea is that it supports all of those scanners that run on the Zebra Scanner SDK. It would, I'd say that if it turned out that some device that works off the regular Zebra Scanner SDK were not actually supported by our filters, by our software, that's something that I would very much appreciate you guys to report. And then by that we will simply report it to the development team and see to it exactly why it might not be compatible for whatever reason. But the idea is, if it's the Zebra Scanner SDK, it got its covered.
Perfect. That goes back to what I was saying earlier about sort of having a unified SDK and a unified layer in there. So yeah, they should all be supported. But yeah, to your point, if you notice anything out of the ordinary, then let us know and we can look into that. We probably only have time for one more question here, maybe two actually. So Andrea just quickly asked, is it possible to have the slide of the presentation with the embossed image on it? I think you should be able to pull that from the video recording. We don't actually provide the slides, so it's just the recording that you'll have to refer back to there. But it was brought up quite a few times, so that should be okay. So the last question then in the last minute here or so, in the case of no red characters, so when it doesn't read any characters, can we train the neural network to read them? So can we improve the algorithm? Can we retrain it?
That is possible, but not exactly directly through our software, through the interface here. This is something we would ask you guys to report to us directly. We've been rummaging over this. We've been wondering about the right approach to how to handle such requests. And we were at first thinking about, maybe allowing users to just retrain the model as they see fit. But after balancing all of it out, we decided that if you guys really need to have the model retrained, then just talk to us. Tell us exactly the opportunity, the size, what it is really about, and we will do our best to help you as soon as possible. But not something you can do yourselves, I'm afraid. Just talk to us and we'll do whatever we can.
Perfect answer. Okay, so that brings us to the top of the hour. If we missed your question, or if you can think of any questions after the webinar, please do feel free to reach out to us. So that's av-support@zebra.com to go directly to the AV team. If it's more general, you can contact us at developer@zebra.com. We'll try to route you through to the correct person. You also have the forums on our developer portal, so developer.zebra.com/forums. And then, of course, all of our social media channels, which I won't go through again. Oh, there you go. Very handy. Thank you. So, yeah, Jarek, thank you once again. That was a great presentation. Really appreciate your time today. Hopefully the audience also appreciated it. I'm sure they do. And we'll see you again next month for the next DevTalk. And I'm sure we'll have you on again.
I'm very sorry about the noise, but fortunately it wasn't there for much.
Yeah, you handled it well. So thank you very much. Okay, so goodbye, everyone. We'll see you next time.